In this example, we're looking at a truss for a roof frame. At the apex of the truss, there's a downward force exerted, and we know that the downward force has a value of 62 kilonewtons. The members of the truss are angled at 75 and 30 degrees above horizontal, and then we have a member which goes across the bottom which ties those two members together to form the triangular shape that we're familiar with for roofing trusses. We're going to try and solve this using the parallelogram method. It should be worth noting that this line is drawn to scale, so my scale is 1 centimeter equals 10 kilonewtons, so this line here is 6.2 centimeters long. The force in the three members that make up the roof truss is unknown, but the directions that the forces point are known. So these lines are just randomly drawn in terms of length, but specifically drawn in terms of angle. I'm going to start by making a copy of the one known force, which is the load on the apex of the roof. So I'm going to just translate this line over to the side here. Draw it in like so. Now that line I'm going to make to scale, so it too should be 6.2 centimeters long. And that would bring us to right here. There we are. Next thing I'm going to do is I'm going to move one of these two forces over to here. And it really doesn't matter which one, but I'm going to start with this one. I'm going to go clockwise here. So it's not as simple as extending the line, because if I extend this line across this way, I miss the end of the known vector. So I actually have to apply my technique where we've got the straight edge of a right angle triangle on the vector I want to move and a guide in which we can move it. And I'm going to slide that over to here, and I'm going to make a copy of that line, but I don't know how long to make it, but I at least understand that the orientation of these two lines is correct because the angles were correct. The next thing I'm going to do is I'm going to take a copy of this line and I'm going to move it over here so it bridges the gap. And it's important to note that the end of this line should meet with the end of that line. So put a straight edge on the vector that I'm trying to move. Put my guide in place and then slide this across until I get to this point right here. And at that point I can draw in a line that goes from there to there, and the length of the line that I just drew now using my scale will be the proper force for this line right here. And if I fill in the line right here, the length of this line that I just drew using my scale would be the force of that member as well. So this is the load that's applied, and this is the force in the two members of the roof truss. I'm missing one member right here, the horizontal one that ties things together, but that one comes right here. So in fact what I'm going to do is I'm going to make a copy of that line, because I know the orientation of all these lines are correct. I'm going to slide it up to here, and I'll put it in right there. So the line that I'm drawing now is scaled out to show me the force of the horizontal member of a roofing truss. And from here on out, it's just grab my ruler and use my scale. So I'm going to start with this one right here. This line measures 1.5 centimeters. So the force here is 15 kilonewtons. This line measures 1.9 centimeters. So the force here is 19 kilonewtons. And then finally, this line measures 5.5 centimeters. So that means the force is 55 kilonewtons. So there you have it. This member, being very vertical, has a high force in it. This member doesn't have to have so much force in it because it's not doing the same job holding the load up, but it does have a horizontal component. The member that you see here is trying to hold things together, so it's actually in tension. It's being pulled apart, and it reacts by pulling itself back together. And these two members here as well are in tension, or actually, sorry, in compression, because they're trying to be squat, and they react by pushing against each other, or pushing outwards.